All right, so let's start with this first example. I just want to go over one more function here before we move on to trigonometric functions. And as always, I'm going to need to shut this off. So we're going to do it without the lines here. Hopefully it's not sloppy. So we're going to go ahead and write f of x is equal to 2t plus 1. That's underneath the 1 to the fourth power. All right, so let's begin. So as always, we take the derivative of the outer function, which is going to be 4 times, we're going to keep that inner function inside the parentheses, and we're going to have 3. So always subtract 1 to that exponent. And now we have to take the derivative of the inner function, which is 1 over 2t plus 1. All right, so what we could do, so this side here is going to stay the same. What we could do here on the right is use quotient rule, or we can use chain rule again. But in order to use the chain rule again, we're going to need some type of exponent to make it look like something like the original function we have here. We need an exponent. What we could do is just take the inverse, and that would just look something like this. So dt, gotta remember it's always t here now. We switch it over to 2t plus 1 to the negative 1 power. Same function, we just now have a negative exponent. All right, let's move down here. Let's keep moving down, and now we just simply use chain rule again, second time. We're going to have negative, so negative 2t plus 1, that's the inner function there. That stays the same, and then we're going to subtract 1 to the exponent, and we get negative 2. And then we're not done yet. A lot of people might think they're done. Well, you still haven't taken from the second chain rule that we're using here. So the second time we're using the chain rule, we haven't taken the derivative yet. Okay? So we have to go ahead and take the derivative of the new inner function, which is going to be, let me rewrite this. It's going to be the derivative of 2t plus 1. That's the new inner function. Okay, and now we simply take the derivative. We're going to rewrite what's on the left over here, 2t plus 1 to the negative 2, and that's just going to be 2 here. So what we have is negative 2, 2t plus 1 to the negative 2 power. And we are done. We can go ahead and rewrite this over down below. So multiplied by 4, 2t plus 1, right below the 1, I should say, to the third power. And you keep it like this if you want, or you can go ahead and put that negative 8 on the outside. Rewrite this as 2t plus 1, right below that 1 to the third power, 2t plus 1 to the negative 2. Let's take a look at this function now. F of x is equal to cosine x squared. So our outer function is cosine here. So we have to take the derivative of the outer function. The derivative of cosine is negative sine. So we have negative sine. And we're going to keep that inner function. And then all we have to do is take the derivative of x squared, which is just 2x. So we're going to have negative 2x sine x squared as our final answer. Now let's go ahead and take a look at another function that looks similar to this one. I'm going to do it in blue here. We're going to have f of x is equal to cosine squared x. So this one's very similar. Now what cosine squared x really looks like is just two cosine functions that are being multiplied to each other. Or in other words, when we have two of the same things, we have them squared. So we can write this function, this original function here, as cosine x to the power of 2, with parentheses, of course. This is not the same as the first one we saw here. This one, the only thing that's squared is the inner function, which is x. Here, the cosine x is squared. So we can go ahead and use the chain rule now. So same function here. The outer function would just be 2, and then we keep the inner function, which is cosine x, and then subtract 1. So we are just left with 2 times cosine x, and then we have to take the derivative of cosine x, and that is just negative sine x. Or I should go ahead and rewrite this as cosine x, and then rewrite the whole thing as 2 cosine x times negative sine x, which we can go ahead and rewrite as negative 2 cosine x sine x as our final answer. This is actually one that's pretty easy to remember. I don't have to do all the work. This is probably one you're going to see a lot. So try to memorize that the derivative of cosine squared x is negative 2 cosine x sine x. All right, let's take a look at our last one here for this video. We're going to have multiple parts here for chain rule. It's a very important chapter, so there's going to be multiple videos on the chain rule. This next one is g of x is equal to e to the power of x squared minus x. Now this one, here's the rule that I like to use. A lot of books don't have it this way, but really when you take the derivative of an exponential function like this one, it really is e to the power of f of x. So you're really just keeping that e to the power of f of x and then taking the derivative of whatever the function is that's as the exponent. So let's go ahead and do the derivative here. We could use chain rule. Okay, we're going to use chain rule since that's what the chapter is all about again. And we have to figure out what's the inner function, what's the outer function. The outer function, sorry if my dogs are barking outside. All right, so the outer function is the exponential function, e. So we're going to keep e, that stays the same, and then we just rewrite x squared minus x. So as you can see, that's basically the first part of the chain rule. It stays the same as we written over here, or as I wrote here on the right. Then we have to take the derivative of the inner function. Well, as I wrote also on the right, we have to take the derivative of f of x, which is just x squared. Let me go rewrite the derivative here. D, and it's not inputting, there you go. D over dx of x squared minus x. All right, and that is simply going to be e x squared minus x, or e to the power of x squared minus x, times 2x minus 1, and that is our final answer.